So as the story of Newfoundland goes, you would never believe this, but about 1 billion years ago, we had a supercontinent, and the supercontinent was called Rodinia. And believe it or not, Rodinia decided to break apart. And so far, we've learned that the breaking of a continent is called rifting. When the supercontinent called Rodinia broke apart, believe it or not, it split right down through the middle of what we now know as the west coast of Newfoundland and the east coast of Newfoundland. And in between, let's say, St. John's and Corner Brook, there was a massive ocean that got created called the Iapetus Ocean. It was all because of the convection currents and what they did and how they basically pulled both apart in opposite directions. We had a ridge, we had seafloor spreading, and both sides were going in two opposite directions at a rate of about 2 centimeters per year. Now, the craziest thing is about 540 million years ago, for some reason that we don't know, the convection currents actually switched. And instead of the Iapetus Ocean getting bigger and seafloor spreading continuing at a ridge, we actually switched back to a convergent plate boundary. So for a very long time, we had an ocean-ocean collision taking place, just like is taking place in Japan and the Aleutian Islands and the Philippines today. We had an ocean colliding with an ocean. There was subduction taking place with a trench, island arc volcanoes, some crazy metamorphism taking place due to the high temperatures and pressure, and eventually the two continents got next to each other again. Now, it's important that I point out that these two continents, the west coast of Newfoundland, is truly a basically piece or a sliver of ancient North America, and that's the west coast, sorry, and the east coast and the continent on that side was an ancient sliver or ancient piece of Africa. And so when the ocean-ocean collision basically came to a close and the two continents were up next to each other, it essentially became a continent-continent collision, which is exactly like we're seeing in modern-day Himalayas. And so the Iapetus Ocean completely disappeared, and this little piece of Africa and this little piece of North America collided. And at that particular time, we had our second supercontinent, and that supercontinent was called Pangaea. And when Pangaea actually was formed, these two continents here in this diagram were fully together, and both continental shelves got pushed together. And that also created one of the biggest mountains in the world at that time, called the Appalachian Mountains. Now, believe it or not, later the convection current switched again and tried to pull apart Newfoundland again in the middle. However, with Pangaea and the Appalachian Mountains having been formed when the Iapetus Ocean closed, Newfoundland basically refused to be split or rifted apart in that same location. So the rifting actually took place on the eastward side of the Avalon Peninsula, and that is the reason why the modern-day Atlantic Ocean is on the other side of Signal Hill this time. In Newfoundland right now, we like to think of it as 3 zones. We have an eastern zone, which is here, which is an ancient part of Africa, a western zone, which is an ancient part of North America, and this whole central zone here is basically the remnants of an old ocean called Iapetus, with evidence of metamorphic rocks and evidence of island arc volcanoes. So they are essentially the 3 zones of Newfoundland. As you can see in this particular diagram, it is over in this area where it got rifted after Pangaea had formed and after the Appalachian Mountains. And this was the start of a new divergent plate boundary, which we now know as the Mid-Atlantic Ridge. And this was also the beginning of our new ocean that we now know as the Atlantic. And so the Atlantic Ocean is getting bigger by 2 centimeters per year because of seafloor spreading along this ridge. Over on this side of the plate boundary right now, we have our little province of Newfoundland that was once a plate boundary but is no longer a plate boundary. And that's the reason why we don't see any active volcanoes and earthquakes in Newfoundland anymore. So we still have our eastern zone, part of Africa, our western zone, part of North America, and this central zone in here, which is essentially remnants of the old ocean and island arc volcanoes. So, as I said, the western zone, some people call it the Umber Zone, which is the ancient part of North America, and the Avalon Zone is the eastern zone, which is an ancient part of Africa, and then we have our central zone, which is mostly ancient Iapetus Ocean crust along with island arc volcanoes. So that basically is the story. So for the public exam and the unit test, it's really important that you know these 3 zones of Newfoundland and what they represent and how they particularly formed. Remember, a lot about plate tectonics was learned in Newfoundland. We learned that continents basically can form supercontinents. We learned that supercontinents can be rifted apart, and oceans can be formed. Oceans can be destroyed. Mountains can be formed. We also learned that plate boundaries can form and they can also end. We also learned that convection currents can also switch direction for reasons that are not clearly unknown. So Newfoundland is a really good case study when you're really looking to teach somebody about plate tectonics. From Newfoundland, we learned a lot about ocean-ocean collisions and continent-continent collisions, and we also learned a lot about rifting and the establishment of divergent plate boundaries.